circuit consists of? Simple, a simple electric circuit. So it consists of a source. Source means what? Source for energy, electrical energy, that is battery. So a source of electromotive force. Electromotive force is nothing but we are getting from battery. And plug key. Plug key. Symbol is like this, plug key. We write K in circuit. And load. Load means any resistance or bulk. Resistance or bulk. Okay. Resistance means we are having this symbol. Bulb means we can just put like this and cross. With ammeter. Ammeter means it is a device used to measure the current. Ammeter form will be like this in the circuit. And voltmeter. Voltmeter to measure the voltage in the circuit will be put by V. So connected, these are all things connected together constitutes electric, constitutes an simple electric circuit, or simply say electric circuit. Okay. So let us, I will give you the time to draw this, write this. Till that time you just see how I am drawing the circuit. First I am taking the source of battery. So battery is represented by one big line and one small line at the center. Big line, we put plus, positive terminal of the battery. Small line, negative. So singly, this is only one. We call it as cell. When two or more cells are connected together, we call it as battery. If it is single, we call it as cell. If more than single, more than one, we call it as battery. So we are connecting now. How? We are connecting this negative terminal to positive terminal of another cell. This is connection. Okay. So two cells are connected. And one more cell I am connecting. Negative to again another positive terminal. Okay. So in this way, three cells are connected together. Three cells are connected together. This forms, we call this as simply battery. Now current flows from positive to negative. So here in the positive side we put key. It is K means key. So current flows, when key is on, current is flowing in this direction. Arrow mark shows key is on, current is flowing. Now here to measure this flow, we put ammeter here. So ammeter reads or shows that how much current I is flowing through this wire. And next we are connecting to a resistance R. So you can note down the amount of voltage drop how much energy is absorbed here. That is potential difference between this point and this point by connecting voltmeter like this. This is called parallel connection, and this is called series connection. This is called parallel connection. Current I is coming here. Now here splitting up here. This is here it is going like I1 and this is I2. Okay. This is also I1. This is I1 means this is I2. So this current I is splitting here. This current I is splitting here into I1 and I2. After reaching again here, this I1 and I2 will become again I. That means here I will be equal to I1 plus I2. Now, if you want one more, you can also add bulb here. This is bulb. You can put B. Again, if you want one more voltmeter here, you can connect and close this circuit. Current I is flowing like this, here moving back. So this constitutes a simple electric circuit. So what we are having here, electromotive force, source of energy, that is more than one cell. There is totally 3 cells are there. So this is a battery, plug key, on off key, and then ammeter and resistance, voltmeter, bulb. These are connected together by a simple wire. Okay, continue. It is called what we call this is simple electric circuit. So all of you write down this definition first. A simple electric circuit means what? Here connected together with wire, conducting wire. Write down a source of EMF, that is battery, comma, plug key, is a symbol of plug key, K, load, load, load is resistance or bulb with ammeter and voltmeter connected together with wire constitutes an electric circuit. Please switch off your microphones. Mute करो. We'll draw this circuit. See, these are very nearer to each other. Small gap between big line and small line. Don't join these two together. Gap should be there between positive terminal and negative terminal. This constitutes a cell. And this is another cell. So this negative terminal is connected to positive terminal of another cell. Positive and negative gap is there. Again this negative is connected to positive and here negative terminal is there. So these 3 cells put together they form battery, source of EMF, electromotive force. So if these are the dry cells, each one is of 1.5 volt. This is also 1.5 volt. This is also 1.5 volt. They are connected in series. So in series, the total voltage is nothing but 1.5 plus 1.5 plus 1.5. So 1.5, 1.5, 3 volts 3 plus 1.5, totally 4.5 volts of voltage is, potential difference is moving, passing through this, across this circuit. If instead of connecting this series connection, if cells are connected parallelly, how many number of cells you connect, 10 or 20 of 1.5 voltage, you will get only 1.5 volt only in parallel. Suppose if you are connecting 1.5 volt one cell and 10 volt one cell, whichever is highest in parallel, that only will be the voltage. So in series we have to add these. We have to add these 1.5, 1.5, 3 plus 1.5, 4.5 volts. So we are generally using in torchlight or radios, putting the cells together, isn't it? This is the way they are connecting together. In this way only they are connecting. Now, after this, we are going to another topic, it is Ohm's law. Ohm's law. Ohm is the name of the scientist. So he has given the law relating voltage and current. Voltage and current. It is, if voltage in the circuit increases, that is, you are increasing number of cells, voltage has increased, then what happens in the circuit? Current increases. If you remove the batteries one by one, what happens? Dim. The glowing bulb will become very dim. This current is decreasing. So if the voltage is increasing, then the current is increasing. If the voltage is decreasing, then the current is decreasing. That means there is a direct proportion between applied voltage or potential difference and current passing through the conductor at the constant temperature. Temperature being constant. Temperature should be constant. That is a condition. Understand? So let's write the Ohm's law. The current in the circuit is directly proportional to the applied is a potential difference or voltage. Applied potential difference in the circuit. The circuit at constant temperature. So temperature being constant, the current is directly proportional to applied voltage. Therefore, what we say, V is the potential difference directly proportional to I. So, to remove this proportionality symbol, we have to introduce the constant. So that is nothing but R. So we are getting R. R is the proportionality constant known as resistance. Okay. So V is equals to IR. This is the Ohm's law. Now this in turn implies R is equals to V upon I, and this is given by ohms. Yesterday I have seen the definition of resistance. It is given by obstruction caused to the flow of current. It is ohms. Now please write down this. The current in the circuit is directly proportional to the applied potential difference in the circuit at constant temperature.
What is the
Wait, let the other people also write. If you have completed, please wait. Now, uh, ohmic conductors. Ohmic conductors. Ohmic conductors means the conductors. Conductors means it is the wires which allow the current, which obey, which accept the Ohm's law, are called ohmic conductors. Almost all the metals except few, germanium, it is semiconductors we call germanium and silicon. Those are having different properties. So other than that, the copper wire, aluminium, and whatever we have, silver, zinc, all these things, conductors will obey Ohm's law. So the conductors which obey Ohm's law are called ohmic conductors. Now let us see uh, the VI graph for ohmic conductors. So we have to plot the graph. It is what we call that as VI graph. VI graph for whom? For ohmic conductors. So we have to take the voltage on x-axis, that is V here and I here on y-axis. Then when we plot, suppose you have connected something resistance. Just now I have shown you a simple electric circuit like this. So just note down the current I, note down the voltage V. Now increase one more cell. Say this is V1, first one V1. Increase one more cell, the total voltage is V2. Note down the corresponding I2. Again increase one more cell, corresponding I3. Again increase one more cell, again corresponding I4. Now take all these values and plot the graph. Take these values on x-axis, I values on y-axis. When you plot the graph, we are getting the graph like this. This is V, this is I, you are getting on x-axis, this is on y-axis, we are plotting I values on. You are getting a straight line passing through origin. This is called ohmic curve. This is called ohmic curve. Understand? So all of you say that this is just like y is equal to mx graph. So y is nothing but here I and equals to y is equal to mx and x is nothing but v and m is the slope. You get on 1 upon r. I is equal to v by r or v is equal to IR in this way. So this is called ohmic conductor graph. VI graph. What no रे कौन सा बेगम? Yes. Yeah, all of you first write down this. I think I have already written once. Wave graph, the conductors which obey Ohm's law are called ohmic conductors. Okay. After that, you draw the diagram. The diagram is the diagram I am putting after you write down this right soon. So we have completed. Please wait.
Over, sir.
Don't shout, I said. Who is that? I said no, just now only. You have completed. Wait. Don't say over.
Okay, sir.
Now draw this graph. Now I am coming to Kirchhoff's law. Kirchhoff's law. So before going to Kirchhoff's law, we have to see what is the graph of the non-ohmic conductors. Okay, so non-ohmic conductors. So the conductors which do not obey the Ohm's law are called non-ohmic conductors. This question, differentiation between the ohmic conductors and non-ohmic conductors, or what are ohmic and non-ohmic conductors, is an important question from the point of examination. Understand? So let us see how will be the graph of this. This is current and voltage. So please write down this soon. Non-ohmic conductor. The conductors which do not obey the Ohm's law are called non-ohmic conductors. And this is the graph will be like this. It's not a straight line. It is a curve like this. Yes, sir. Like this. Or sometimes it will be like this also. This is origin. It is not a straight line passing through origin. It may be a straight line like this. An example: semiconductors. Germanium, silicon, etc. And for examples for those things, all aluminium, copper, that thing you can take from it. Now, I hope you have drawn this soon. Now, going to Kirchhoff's law, or sometimes we call Kirchhoff's current law, KCL. So what is? We have two laws for that. So today we let's see only the first law. This is also known as junction rule or junction law. Kirchhoff's current law or Kirchhoff's law or junction law. These are the names given. What is junction first of all? So when two wires, two conductors means two conducting wires, it is when this wire comes here and this wire comes here. Two wires are joined together. This is not a junction. This, when two wires join, we call it as node. What do you call? Node. What we call? Node. So there should be more than two wires. So another thing. You can say this one. So it's the point 2O we are taking. At this junction, 1, 2, 3. 3 wires are meeting. Then it is a junction. If only two wires are meeting at one point, that is a node. If three wires are meeting, we call it as junction. So there is a difference between the junction and node. Node means only two wires. Junction means three, not only three. You can also say one more wire, more than three. Three or four or five. You can say another is coming like this. So these totally five wires are there. It is a junction. Oh, say 1, 2, 3. You can say this is 4 and this is 5. Now, what the law says, that some of the current coming in, suppose the current I1 is coming from here, oh, I2 is coming from here, I2 and I3 is coming from here, but leaving here I4, I5, the algebraic sum of all the currents coming in is equal to sum of the currents going out. Sum of the currents coming in is equal to sum of the currents going out. That is called Kirchhoff's junction law or current law, KCL. So here what we say, coming in is I1 plus I2 plus I3. This should be equal to going out, I4 plus I5. So conservation of current. Principle involved is conservation of current. What we say, the sum of the currents coming towards the junction, towards the or we can say at the junction. Instead of towards, we can say coming at the junction is equal to the sum of the currents going away from the junction, So 1 minute है, थोड़ा जल्दी उतारिए. This I think you have drawn. And then you write this. So from 24th onwards, you are having online classes from DD, Doordarshan Yadagiri, and TSAT, okay, and 50% staff will be available as far as